Okay, so we are saying that to examine the trend or measurement of underlying trend, okay, the essential aim of time series is to use past information to establish and plan for, okay, next periods ahead. This is achieved effectively by measuring the secular trend or the underlying trend, which depicts the general direction of the trend line over time. Good. And the trend is, or underlying trend is influenced by population changes, productivity improvement, technological changes, and so on and so forth. Okay. So as the population is increasing, so many economic variables, okay, will also what, um, fluctuate in terms of decline or increase. Okay, good. So it will even affect issues of health and so on and so forth. Okay, so population, or let me say demographics, okay, changes influences both economic and health and other series. Okay, productivity within a company also influences their trend. Good. When they are being more productive, then it means that we are going to see what, an upward trend. Okay. Whereas when productivity drops, then we are likely to see trends going down. Okay, good. Now it says, why examine the trend? When a past trend can be reasonable expected to continue on, it can be used as a basis for future planning. Okay, that is the more reason why we have to examine the trend within the given series. So we examine the trend to be able to forecast what is going to happen in future and plan toward that. Good. There are various techniques which can fall on. The first one is using a graphical technique. The second one is semi-average method. We have the moving average techniques, least squares, and exponential smoothing techniques. Okay. Now let me move on. So given this data here, we to plot the free or let's say graphical technique, it's just a matter of plotting your time on the x-axis, okay? Because now it becomes a time axis, and then your observations on the y, okay? And once you do that, you get this series, and then fits a line of best fit to the data for forecasting purpose, okay? But of course, it comes with a lot of issues, okay, when we use this technique, okay, as we are aware of. So, now, the next technique will be semi-average technique. Semi-average technique just means you are going to divide the data set into two equal halves, okay? So if the data starts from 2012 to 29, I think it's about 9 series. 9 series, the center is somewhere in the middle. So we can divide it into half, and then find the averages for the two halves. Use those 2 points and then plot the data. So from 21 to 2005, we find that half. Then from 2006 to 2009, we also find the average there. Then using those observations, you plot. So we have 20, this is the average. So 2021 to 2024, we have this point here. Then the next one is the 2728 data. You have that and you plot. But of course, this also comes with its own challenges, okay, which we will not be looking at now. Then the next one we're going to talk about is the moving average methods, okay, which is a very common technique used. This method is based on the premise that if the values in the time series are averaged over a sufficient period, the effect of short-term variations can be reduced, okay? Good. Then what we mean by short-term variation is we are talking about seasonal, cyclical, and irregular variations, okay? And anytime we do moving averages, these variations are smoothed out, resulting in a smooth graph depicting the overall trend. So this gives us an indication of a trend, whereas the other variations are smoothed out of the data. Okay, now the next point, the degree of smoothing can be controlled by selecting the number of cases to be included in the average. Okay, so we have to decide on the moving average order we are going to use. Okay, good. Now, it says the technique for finding a moving average for a particular observation is to find the average of m observations, and after the observation itself, that is a total of 2m plus 1 observations must be averaged each time a moving average is calculated. So we have a data here, okay, and in the next slide we will be looking at the 3-year and the 5-year moving averages. Good. Now, so we bring back the data for a 3-year moving averages, okay? It means that we are going to average these 3. Do you understand? That will be the first observation here. So if you look at the calculation down here, this is the total. Here we are adding them up. This is total. Then the average is divided by 3 because we are doing a 3-year average, okay? So the total is 13 plus 15 plus 17 gives you 45. Then divided by 3 gives you 15. Then the next one will be 15 plus 17 plus 18. Okay. When you add, should give you what? 50. Divided by 3 will give you 16.67. Next will be what? 17 plus 18 plus 19 gives us 54. Okay, divided by 3 will give us 18. Then you follow the same technique. 18 plus 19 plus 20 should give us 57. Okay, divided by 3. So that is how we compute the 3-year moving averages. Okay, good. Now, the next thing you need to understand is anytime you are placing your moving average, it should always be in the middle, okay, of the numbers. So in this case, because it's odd, it should be placed in the same row as 15. Okay, the computation should be placed in the same row as 15. Good. Now let's move on. Okay, in this scenario, we have a 5-year moving average. So it means we go 5 years. This is 5 years. This is the first 5 years. When we add it, you get 82. And then when you divide by 5, you get 16.4. Then you should take note, it should be placed in the middle of the 5. So it's placed with the 17, okay? Then the next 5 years will be from 15 to 20. When you add them, you get, let me bring it up, 689 divided by 5 gives you that, okay? Next 5 years will be from 17 to 20 here, okay? Next will be from what? 18 to 21. Next will be from 19 to what? 22, okay? And we are done with the computation. Very well. So once you get a total, then you divide by, okay, you find the average by dividing by 5. Okay. So that is it for 3-year and 5-year moving averages. Okay, good. Now, this is for a 4-year moving average. Okay, 4-year moving average, because it is odd, even in AMA. Okay, we will need an extra step. to align the trend values, okay, or the average you have computed. What you do is you compute a 4-year though, right? So it's 4 years. The total, like I said, should be placed in the middle. So 63 should have been placed in the middle here, but it doesn't correspond to any year. You understand? So which means that ideally, this would have been 63. Then the 69 too will be in between 17 and 18. 74 is in between this. Okay, good. So we need to align it with a year, right? So what you do is you have to first, this is the total. So first you find the average. Once you find the averages, that will be 15.75. Don't forget it's in line with this one, which is in the middle. It's not aligned to any year, okay? So when you are done, you have to come back and then find the average of the two, okay? And when you do that, that will help you to get a figure which will align to a particular year. Good. So we do this to align, for alignment purpose. Good. So after you've computed your moving average, come and take the next, 2 years, divide by 2, so that the figure that will come will align with a year, okay? And if we have to plot it, then we can have the year with its corresponding trend value. Okay. Now, moving on, the next technique is the least squared methods, okay? And there are 2 ways in which this can be done, right? So we can take, for example, the middle value of the year of the data to be equal to 0, okay? And then reduce preceding years by 1 and subsequent years we increase by 1. Or we can just use the normal regression method where we start, first series is 1 and then we keep going to the end, okay? But in any case, it's still least squares linear regression model, okay? So which means that YT will be okay, equal to A plus beta X, okay? But this time your X is going to be the previous observed data, right? So what you need is your summation X, your summation XY, okay? You also need your summation X square, okay? To come out with your coefficients of the model. So we know from our regression analysis that A is always summation Y over N minus beta summation X over N, okay, where your beta naught is also what? Beta is what? N summation XY minus summation X summation Y over what? N summation X squared minus, let me correct this. So this is N summation X square, okay, minus summation X all square, okay? That is a little correction here. Good. Let's move on. Good. So that is the technique we are using here. If you look at the data, this is the same data we saw earlier, okay? But this time around, you are going to align them. We are using the normal regression technique, okay? So the years will be, let me say, coded from 1, assign the value 1 to 9. Then you find your X squared, because we are interested in summation X squared. We're also interested in summation X all squared. So we have to find summation X. Okay, we're also interested in summation XY. Okay, and we are interested in summation, okay, Y squared as well, right? summation x squared is just square of this. So 1 squared is 1, this square is 4, this squared is what? 9, this squared is what? 16, 25, okay, 36, 49, 64, and then 81, okay, good. Then you sum it up. Summation xy is just this times this. So that will be 13, 30, and etc. Okay, 51. So we keep going. 72. So basically that will be it. 95, then 120, and so on and so forth. Okay, 140. Then you sum them up. You understand? Then we also have y squared. Square the values of y also here, and then sum them up. Okay. And once we are done, you come and put it in the formulas we saw earlier to find your A and to find your just a moment, please. Okay. Very well. So which means that at the end of the day, we are going to get this model, okay? We are going to get this model for, okay, the forecasts. And of course, every year, the sales for the next year will be obtained by just increasing X by 1. So if you want the sales for, let's say, 2014, okay, or it says, what is the predicted sales for 2013? So you go and look at the value for 20. Let's go to the table. Sorry. Okay. So we picked, this is using the second technique, but 2013, so we have 2011 is 9. So 2012 is going to be 10. 2013 is going to be what? 11, okay? So if you want the forecast, you just put it into the formula here. And then you are going to get your forecast for 2013. But like I said, there are 2 methods of doing this, right? The first technique, which we've already looked at, okay, by assigning your yearly value starting from 1 onwards, right? But in the second technique too, we could have started from the middle, like I explained earlier. We could have assigned 0 to the central point here, right? And then decrease the values, okay, previous values, whilst we increase, okay, the values of X for subsequent values. And then rerun the same model, okay, using the formulas provided in the slide. So that is how you go about the least square regression methods to come up with your model for trend analysis. So based on your the model, you can forecast using that least squared model. You can also make forecasts for the next 1, 2, 3 years, okay, given the based on the given data. Okay, good. Yeah, now before I move on to the exponential smoothing technique, if you have any questions, you can bring it up.